Thank you all very much for still being here. So I think I'm the last thing between you and like the beer and food outside. So I try to hurry up and stick to my 15 minutes. I have your countdown here. So I want to be talking about how to deploy like a fast data pipeline on top of DCOS. So I try to fit this into this 15 minutes. Just a short question up front, like how many of you have actually used or heard of Apache Mesos or DCOS before? Oh, quite some, like about half, I would guess. Don't worry, we'll also catch up the rest of you. So that's actually me. I'm a distributed systems engineer and occasional advocate at Mesosphere. So I actually started developing, I'm one of the contributors to the Apache core project, and I'm also like here at events talking about Apache, Mesos, and actually also DCOS. More interestingly, what has actually happened in the application landscape over the last years? What we're seeing, it all started out with like this old magic Hadoop. And Hadoop was like one of the first frameworks which actually wanted to take control over your cluster. So usually back in those days, Hadoop was like the framework, and you had a Hadoop cluster running somewhere in your data center. But actually, the workloads have changed over time. So we moved over. Hadoop was kind of like very inflexible, and we had like delays from like days to hours. And actually, this wasn't fast enough for most workloads. So there we actually came up with Spark, as we're here at Spark Summit, with like micro-batching, and we actually received latencies of like minutes to seconds. Still, for like other stuff, this is still not fast enough, and we talk about response times in the microsecond range, and there we actually need something even faster, as for example Apache Flink or Storm, in those cases where Spark streaming isn't responsive enough. So actually, as we can already see, we have a bunch of different use cases from batch over micro-batching to event processing, and actually all of them are valid use cases. So to dive into this use case of like event processing, or actually also in general like this fast data processing, I actually picked up like a quite common example, which is referred to as SmackStack. So SmackStack actually stands for Spark as the data processing tool. It stands for Mesos as basically the cluster layer underneath. Akka is like a nice way of writing like actor-based frameworks to actually process the outcomes of your analytics. And then we have C, which stands for Cassandra, and then we have K, which stands for Kafka. And this is often used to form like such kind of data pipeline, where we started with some events. This can be like some IoT data, this can be sensor data, this can be credit card stream, and then we need some way of getting this into our cluster. And so what we don't want to put it directly to Spark Streaming, because we don't want to couple that. And we also need like a queue in between. And like a common thing used there, and which we probably all heard in multiple talks already today, is Apache Kafka. Then comes the streaming or the analytics tool, which often Spark Streaming is being used for. And then we actually also have like the need to store the outputs of our analytics. And in the end, actually act also up on this. So we already have like 4 solutions which we need to deploy here, and 4 solutions which we need to first deploy and manage on our cluster. And the problem here is that actually what we still see with a lot of users, with a lot of customers as well, is they start out and they actually start to sub-partition their cluster. So they go there, they pick the first 4 machines, and on the first 4 machines, they're going to use them for Spark. The next 3 machines, they're going to use them for Kafka, and so on and so on. They potentially also have some microservices, some Cassandra. So they actually end up with like subclusters within like their large computing cluster. And this has several disadvantages. Like the first big disadvantage is that this is quite static. So I, as an operator, I have to go in, I have to create that setup. I also have to react upon when something fails. So just maybe one example, like in the first years of Twitter, they would always meet on Fridays and actually figure out which services had failed. They had like a big spreadsheet, and then they were like, oh, I have to start 5 new instances of Spark, for example, or 5 new instances of this service. And this is, of course, something which you don't really want to end up doing. And the second problem is then also like, as mentioned before, failures. What happens if not the application is failing, but actually nodes in your system are failing? And so, for example, here in the microservice sub-part of the cluster, which usually is the user-facing part of your cluster, some of the nodes are failing. Then actually an operator has to step in and manually move over nodes from, for example, the Spark cluster or some other sub-part of the cluster over to this really important, because user-facing part, and keep user latencies and users happy. And this is actually where Mesos and DCOS come in. Mesos was, for those of you who have been in the keynote, actually has been developed by the same group of people who developed Spark. And actually, initially, Spark was like one of the demo frameworks on top of Mesos to show how easy it is to write distributed frameworks on top of Mesos. And so the idea, the vision behind Mesos and DCOS is actually that you don't care about like subclusters. You don't care on which particular machine something is running. You take your entire data center as a form factor. So similar as with my laptop, where I simply say I don't care on which core, on which CPU my web browser is running, you have the similar view on your data center. You basically say I want to allocate so many resources to my Spark framework, and that's somewhere in my cluster, and on which nodes that actually is going to happen, I don't care too much about. And if one of those nodes fails, I also don't care about, because I said I want to have 10 gigabytes of RAM and 5 CPUs. This should always hold true, no matter what kind of nodes are failing within my cluster. And that's actually then where DCOS comes in to help, because DCOS is actually, it's built around this Apache Mesos project, and it gives you like everything you need to run and deploy it efficiently. So it's basically this abstraction layer between your nodes underneath, like between your infrastructure, which can be anything from physical nodes in your data center to cloud machines to Amazon to virtual machines, so anything you want to run it on top. And then actually this abstraction layer gives you the opportunity to run anything on top you like. And so the big two use cases we're seeing are on the one hand microservices, so the typical like Docker containers, and on the other side the big data stack, so basically like the stack we saw before with Cassandra, with Spark, and all those frameworks. And yeah, let's actually see that in practice. I have 7 minutes left, which is perfect. And the demo I would like to show you is actually, it's something our customers are actually doing in real production clusters. And this customer is actually, it's Esri. And what they do is like a lot of geospatial data. And the demo we're going to see here is actually we're going to track taxis across New York City. So we're going to have like heat maps and see like how are taxis distributed in New York City. And how we're going to set that up is actually we're going to use some source. In this demo, we're not going to use real-life taxi data, but we're going to use a generator, which is generating those positions. And this is actually then being fed into our Kafka queue. This is being processed by Spark, and then it's actually eventually stored in Elasticsearch. Because actually, Esri has written like a nice plugin into Elasticsearch, which allows him to do really efficient spatio-temporal queries, so they can actually query based on position and based on time. So basically, we can also go back in time and figure out where has this taxi been like an hour ago, where has this taxi been like last week, for example. And if we recall like how our SMAC stack was looking like, this is pretty much like our SMAC stack. We have on the left-hand side, we have like the data source, the event source, then we have our message queue, our analytics, storage, which is not like the SMAC stack of storage, but it's like Elasticsearch. And then on the end, we have like our actors acting up on this data. And this brings me to my cluster. So what we see actually here, it's the first view of our cluster. So this is when I log into DCOS, and this already shows something quite interesting in my opinion. It actually shows like the focus I have as an operator. As an operator, when I log into one of the systems, I not necessarily care too much about the number of nodes, but I more care about how utilized is my cluster. If my cluster utilization is at like 99 or 95%, that's an event where I want to be paged as an operator, because then something is actually wrong in my cluster. Similar with like memory allocation, and similar like with the service health of my applications. As we can see, I already installed like one application because that's taking a while, but what we actually have here, it's a really simple way of installing applications. So actually, all I did to install Kafka in this cluster was I went here to our so-called universe, which is kind of like the app store for your cluster. I went here, click install, and I'm not going to do it again, but this is basically how I just installed this cluster before. We can do the same thing via the CLI. So I can actually control this entire cluster from the CLI. And this is actually what I'm going to use to install now Elasticsearch. So Elasticsearch, as Rias mentioned, they have like a special version. And so I'm actually going to install that as a Marathon app right now. So here's a simple JSON file I can show to you in a second. And we already see there's a deployment. If we look at our cluster, we see that the allocations is going up. And actually here on the right, we see that Elasticsearch is currently idle because it's still being installed, but it's currently being deployed in the cluster. This file, actually, if we look at it, it's a rather simple description. So it simply specifies here some arguments which we use to start it. And as we can see, this is a simple Docker application. It's going to pull this Docker image, which is actually like the longest thing why we still seeing it like idle, or actually right now it finally started. Cool. So now we have our storage layer up and running. And the next thing I'm actually going to have to do is I have to create the Kafka partitions. So we're going to have a data source. And in Kafka, you usually have so-called topics, which are kind of like the data pipes, the named data pipes we want to write to. And so actually, I can also do that from the CLI here. So this is very nice that it actually allows all those applications to also integrate into the CLI. So I can do DCOS Kafka topic, create taxi. I want to have 3 partitions. I'm going to leave out partitions. And it's creating my partition right now. Cool. So we see we created that topic. We can even check Kafka topic list. And now we hopefully see, yes, we have our topic Kafka here. Pretty cool. So now I'm actually ready to deploy my data source. So data source is a thing which is actually generating the positions of the taxis throughout New York City. So let's do that. DCOS Marathon app at source1 JSON. Cool. So this is also being deployed. Looking at our cluster, yeah, we see here a slight increase of CPU allocation. That means that it's actually using more resources and currently being deployed. The next part, which we can actually already start deploying, is the actual analytics job. And they are actually called RATs, real-time analytic tasks. So we're also going to add those to the cluster. Also, this is currently being deployed in idle. And while we are actually waiting for this to deploy, let's have a short look here at our service tab. So services are basically all the long-running services which are being maintained by DCOS and which are being supervised by DCOS. So for example, if I go into source, we see that there's currently 1 task. I could actually now go, if I want to generate more data, I could go in here and scale it up, which I won't do right now because it's still staging and starting up. So now it's running. The other thing which we can do, we can, for example, have a look at Elasticsearch here. So this is the UI of Elasticsearch. We can actually also go to scaling. And I now could go here and actually add more. Let's do that. Let's add a sixth one. So scale. And we should see that, yeah, here we have our staging task. So we actually just increased our Elasticsearch cluster with another node. OK, the last part which is missing, so it seems like our system, besides the real-time analytic task, is almost running in the cluster. So the last part missing is actually we need to visualize this entire stage pipeline we built. So there we actually also have our own Docker container, which is basically a web server. And this is app at the GUI. Yeah. Cool. This is deploying. Also, our red tasks are running right now. Pretty cool. And now we just have to wait till the GUI is deployed. We can already check. So this is my public agent. So basically, DCOS has a notion of two different kinds of systems, or two different kinds of nodes. There are ones being exposed to the public, and then there are ones which are basically private to the cluster. So I actually installed this web server on a node which is exposed to the public using constraints. And let's actually see whether it's already there. Yes, that looks good. I'm not seeing my taxis now, but that means it's pulling data. So we are just waiting for the taxis to show up until it connected, which hopefully happens any second. Call Uber. Let's actually have a look whether we are generating data. So let's have a look here. So actually, I can now, no matter where it's running, actually check the logs of my task, and I see it's generating some data. And also, those seem actually fine. Initial job has not accepted any resources, which hopefully is not a too severe Spark warning. Yes. I sacrificed the demo gods. So now we can actually zoom in. It just took some time to connect to the Elasticsearch. And here now we can actually see like clusters of where taxis are located. I can actually move over to heat maps and basically keep track like where might taxis be missing. So what S3 is using it also for is, for example, to track ships across ports, or actually to figure out, hey, which areas of New York City is underutilized? Where do I have more users than I actually have taxis? So where should I actually send more taxis to? And yeah, this actually brings me to the end of my presentation. And I'm just 3 minutes over. So thank you very much for sticking for 3 minutes more. Time for questions. How much time do we have for questions? 2 questions are fine? OK. Yeah?
So in this model, this was a cool presentation, by the way. In this model, it seems like you built this cluster with a number of services to support what's essentially one application, which is taxi tracking, right?
Yeah.
But elsewhere, you would probably have, in a sizable organization, you might have a general purpose Spark cluster for ad hoc or another Mesos cluster. So organizationally, how does one handle this where it's like, I have to be an expert in these 5 technologies to support the taxi tracking. I have to maintain a large-scale Spark cluster. What have you seen in ways that could effectively support this? Because it is compelling for numerous reasons.
Yeah. So if we're going back to this slide, I think a decent setup, if I want an efficient and fault-tolerant setup of such kind of streaming pipeline, unfortunately, I need to rely on those technologies. And what I can tell you from talking to users and customers, it's important to really understand, for example, that Cassandra is not a traditional relational database, because it's different. And this is like the stack I should understand, and those technologies, because this distributed new world is it's different. DCOS actually helps you to abstract a little bit away from that. As you saw, like with the CLI, we can simply create topics from the CLI. I don't have to become an expert with like a Kafka internals. I don't have to spin up like a Kafka container and connect to it. But still, I would say you need a decent understanding of those different tools and how they fit together. In large organizations, you end up with either having like one big Kafka system for everyone, or actually what I would recommend is have multiple Kafka systems on maybe a shared cluster. But basically, this is something which like an IT department is going to set up, and you as a developer, you should still understand the semantics and the use cases, but it's being set up for you in like one big infrastructure. There was a second question.
So how these events are ingested into the Kafka cluster there?
How are events? The
events that the whole data everything is an event there, right? So all this data, how is it ingested? So you have spun up a source file or something like that.
Yeah.
So is it a customized producer, Kafka producer, or what is exactly?
So this is just a Scala program, very simple program, which actually reads from a CVS file, and actually it's just putting it into the Kafka queue, into this. We created this topic, right? We created the topic taxi, and it's actually just writing into this topic taxi.
So it is just reading from an external file system and just pushing it to Kafka.
This can be anything. It could be any IoT sensor data writing into the Kafka queue.
Oh, okay. Yeah. Okay, thank you.
Then I hold you up long enough, and I don't want to stand any longer between food and beer. Thank you very much for sticking around longer.